Namaskar. In this short clip, we are going to study about electric force or Coulombic forces between two charges. So the electric force and Coulombic forces, these are, you can say, the different forces. As electric force is the force exerting on an charged particle which is in an external electric field. Okay, and the Coulombic force is in between two charges that are uh, separated by some small distance or large distance, that the Coulomb force. So first we shall study electric force. What is electric force? Electric force, when a charge, as we know that when a charge is in an electric field E, then force on that charge particle will be as F is equal to Q into E. That is our electric force. Q is our charge of that charge particle, and E is the external electric field E in which that the charge particle is placed, and F is that force on that charge particle. And as magnitude wise, if we write force on that charge particle, that will be only QE, and in the vector form that is this. So you can say that the direction of that force on that charge particle will be same or is will be equal to that of electric field. Okay, so the direction of force and electric field both will be same. So this is the electric force. And Coulombic force between two charges is, as electric field's force is only on one charge, the Coulombic force will be on two charges. That, as according to gravitational force, which we will study in the next lecture, which is similar as the electric force. So in the Coulombic force between two charges is proportional to the product, that is the proportional to the product of magnitude of those charges, and inversely proportional to the square of distance which by which the two charges are separated. That is, F is, you can write as F is proportional. Product of that charges, two charges, if I write Q1 and Q2 are our two charges that are separated by distance r, small distance r, then force in between these two charges will be proportional to product magnitude of product of these two charges Q1 Q2, and inversely proportional to the square of distance by which these two charges are separated. So this is the force magnitude. So if I want to remove this proportionality sign, then constant of proportionality here is 1 by 4 pi epsilon naught, that is into q1 q2 over r square. This is the magnitude only. If I want to write its vector form, then F will be 1 by 4 pi epsilon naught q1 q2 over r square into r cap. R cap is the unit normal vector, unit vector, normal vector note. This is the unit vector in the direction of position vector. As if I want to write as q1 is at origin, if I want if I say that q1 is at origin and q2 is distance some r, then the position vector, if I want to draw a position vector of q2 from origin, then this will be in this direction, and this direction is shown as r cap, which is the unit vector in the direction of position vector of q2. Okay, so if in the magnitude formula, if there is given that q1 is positive or negative, then we shall use only positive sign here. In magnitude formula, we use q1 and q2 both positive. Whether q1 or q2 both are given negative, then we use only its magnitude. Magnitude is always positive, so we use q1 and q2 both positive. And in the vector formula, if q1 is negative, use given sign. Means if q1 is negative and q2 is positive, then put value of q1 with sign that will be negative, and q2 with positive sign that will be positive if given as according in the question. So in the vector formula, the q1 q2 are placed in the formula you with along with the sign given in the question, and in the magnitude formula we put only the magnitude of q1 and q2 that will be positive. This is the small concept of solving the question also. And as r cap, it can be written as r cap that is unit vector, that will be vector upon its magnitude. Hence, we can write here as F is equal to 1 by 4 pi epsilon naught q1 q2 over r square into r vector divided by r cap. Sorry, r. That will be 1 by 4 pi epsilon naught q1 q2 into r vector divided by r cube. If here r vector is the position vector of charge q2, if we have placed q1 at origin, if I take origin somewhere else and place two charges at some different points, that is q1 and q2, then the position vector will be as, if q2 has position vector r2, and if I enlarge this figure, then if I assume that q2 has position vector r2 and q1 has position vector r1. So the position vector between this q1 to q2 will be in this direction. That will be this plus this becomes r2. So r1 plus this, if I want write as r vector, then r vector becomes here r1 r1 r2 vector minus r1 vector. So in that formula, we put the value of r2 minus r1. That will become as 1 by 4 pi epsilon naught q1 q2 divided by r. Its magnitude will be r vector, magnitude will be r, that will be r2 vector minus r1 vector magnitude. Hence, in this formula, by putting this magnitude cube, that will be r2 vector minus r1 vector magnitude whole cube into r2 vector minus r1 vector. Okay. So this is our vector formula. Done. And if I want to solve the questions on this basis, then we will put the q1 and q2 in the vector formula along with the sign. Use negative if charge is given negative, use positive if charge is given positive. And in the magnitude formula, we use only, this is our magnitude formula, we use only q1 and q2 both magnitude, that will be positive charges only. Done. So in the next lecture, we shall study about gravitational force similar to the electric force. Before leaving this channel, please leave a comment in the feedback as a feedback so that I can improve my video lectures, and also subscribe please. It's a humble request to subscribe my channel because it is under growth. Okay, so please subscribe and share with your friends. Till then, have a good day.